We need to show that the following 4 points are the vertices of a parallelogram, and subsequently we need to check whether if it is also a rectangle or not. Let us begin. Let us consider a quadrilateral A, B, C and D. We'll suppose that the coordinates of vertex A, that's 4, 5. Coordinates of vertex B, let it be 7, 6. Coordinates of vertex C, let it be 6, 3. And the coordinates of vertex D, let it be 3, 2. Now what we'll do, we'll join A and C, and we'll also join B and D, and that is going to give us the two diagonals of the quadrilateral. Now in the first step, what we'll do, we'll try to find out the midpoints of the diagonal AC. In order to find out the midpoint of diagonal AC, all we need is the information regarding the endpoints of the diagonal. Since we already have the value V and C, let's find out the x coordinate first. So what we'll do, we'll take the sum of the x coordinate of the endpoint, so that's 4 and 6, and then we're going to divide it by 2. Then we're going to add the y coordinates of the endpoint, so that's 5 added to 3 and divide by 2. That's going to give us the y coordinate. So solving this, we get the value 5, 4. That means the coordinates of the midpoint of diagonal AC has the value 5, 4. Similarly, we can also obtain the coordinates of the midpoint of the diagonal B. Let's start with the x coordinates. So what we'll do, we'll add the x coordinate of the endpoint. So that's 7 and 3. So we have 7 added to 3, and then we are going to divide it by 2. Next, what we'll do, we will add the y coordinates, and we have 6 plus 2 divided by 2. So this also gives us the value 5, 4. Now this tells us that the midpoint of the diagonal AC and midpoint of diagonal BD, they are equal, which means they coincide with each other. And since the midpoints of the diagonals of both AC and BD are equal, we see that they intersect each other at the common point E. Since the diagonals bisect each other, therefore we can say that ABCD is a parallelogram. Fine. Next, in order to show that it's a rectangle, then the diagonals must be equal in length. So let's first find out the length of the diagonal AC. All we have to do is use the distance formula. So we'll take the square root underneath the square root. First, we need the square of the difference of the x coordinate, and then we will add it to the square of the difference of the y coordinate. So here, the x coordinate will be, difference of the x coordinate will be 4 minus 6. So that's negative 2. And the difference of the y coordinates, that's 5 minus 3, so that's going to be positive 2. So this is going to give us a value 2 times square root of 2. Let's obtain the value of the length of the other diagonal PD. So PD is going to be, we'll have to take the square root. Underneath the square root, first we'll take the difference of the x coordinate, square it, and then add it to the square of the difference of the y coordinate. So let's find out the difference of the x coordinates. We have 7 minus 3, so that corresponds to 4. So we have 4 squared, and then we have the difference of the y coordinates. So 6 minus 2, that corresponds to 2. We have 2 squared. Now 4 square is 16, 2 square is 4. So this is giving us a value square root of 20, or simply we have 2 times square root of 5. Now clearly we see that the length of AC is not equals to the length of BD. So this implies that ABCD cannot be a rectangle. It is a parallelogram, that's for sure, but it is not a rectangle. Hence,